Welcome to Level 1 of the Pesky Pigs Challenge. After years of angry birds flinging themselves at pigs, the tables have turned. Now pigs have started to fling themselves back at the birds. In fact, the pesky pigs rain down upon the birds, crushing the delicate nests under their big bellies. You have gathered enough timber to build a big shelter over the birds and their nests. To shield them correctly, you'll have to build it at the exact coordinates where the pigs will land. But how can you tell where the pigs will land before they've even been launched? Well, let me help you with an equation which represents the flight path that the pigs will follow. Y equals negative x squared plus 12x minus 20, where y denotes the elevation of the pig and x denotes the distance traveled. In order to find the exact position of where the pigs will fall, we need to find the zeros of this polynomial. In the previous lectures, we came across quadratic polynomials and quadratic equations. We have seen that the graph of a quadratic polynomial is a parabola, and by setting that polynomial equal to 0, we can find the values of x where the parabola intersects the x-axis. These values are known as the zeros, or roots of the function. Let's take a look at the different ways in which a quadratic function can intersect the x-axis. We'll start with the simplest quadratic function, y equals x squared. Setting this function equal to 0 gives us the quadratic equation for this function. The only value of x which when squared is equal to 0 is 0 itself. Therefore, the quadratic function x squared has a single x-intercept at the point where x equals 0. Now, let's do the same thing with a slightly more complicated quadratic function, x squared minus 4. Setting this function equal to 0 gives us the quadratic equation x squared minus 4 equals 0, or x squared equals 4. There are two values of x which when squared are equal to 4, positive 2 and negative 2. These two solutions can be written as x equals plus or minus 2, which corresponds to the 2 points where the function's graph intersects the x-axis. When the graph of a quadratic function intersects the x-axis, it can have either 1 or 2 intercepts, and thus 1 or 2 roots. As we have just seen, solving a quadratic equation of the form x squared minus c equals 0 is as easy as finding the square root of c. The same is true for equations of the form ax squared minus c equals 0, because if we transpose the term c and divide the equation by a, we get the same type of equation as before, except that we take the square root of c over a instead of the square root of c. On the other hand, quadratic equations that include an x term can be more difficult to solve. There are a number of methods for solving quadratic equations like this. The methods we will examine in the next few lectures are based on the zero product property. So, what exactly is the zero product property? Let's say that we have a number or expression, which is the product of two or more factors. For example, let's assume that the product is composed of two factors which we will call a and b. The zero product property states that if any factor is equal to 0, then the product of those factors must also be 0. The same logic applies to the linear factors of a quadratic expression. As we shall see in future lessons, the polynomial representing the flight path of the pigs can be expressed as a product of two linear functions, negative x minus 2 and x minus 10. When x has a value that causes any of these linear factors to be 0, then the corresponding quadratic expression will also have a value of 0. This seems obvious since the product of anything multiplied by 0 must be 0. But the zero property also states that the converse is true. If a product of factors is 0, then one or more of the factors must be 0. Therefore, we can find the zeros of a quadratic function by finding the zeros of the simple linear functions that are its factors. In our case, the zeros of the polynomial negative x squared plus 12x minus 20 are equal to the values of x, which makes negative x minus 2 and x minus 10 equal to 0. In other words, x equals 2 and x equals 10 are the two zeros. Feel free to build your shelters at these points and protect the pesky pigs from killing the angry birds. In case you're wondering, how many zeros does a constant polynomial like y equals 2 times x raised to the power 0 have? Always remember that such a polynomial has no zeros at all, because replacing x by any number in 2 times x raised to the power 0 still gives us 2. In general, a non-zero constant polynomial has no zero. On the contrary, the zero polynomial has an infinite number of zeros. No matter which real number you plug into a zero polynomial, the result will always be 0. Now that you know what the zero product property is, you're all set to find the solutions of higher degree polynomials. As always, thanks for watching, and see you next time.